Good afternoon, all the participants. Today we are having in this session a very eminent personality in teaching field, Dr. Deepmala ma'am, with us. She is presently working as an assistant professor in Triple ITDM Jabalpur. Her area of interest in which we can take help from her are the optimization theory and applications, non-linear analysis, operator theory, integral equations, dynamic programming, fixed point theory and applications, non-linear programming, approximation. So we can take help from her from these type of research areas. She has done her PhD in mathematics from Pandit Ravi Shankar University, Raipur, and postdoctoral from Indian Statistical Institute, Kolkata. Presently, she is working in Triple ITDM, Jabalpur. She has also been a visiting scientist in Indian Statistical Institute, Kolkata. She has got a Young Scientist Award during 21st International Conference of the International Academy of Physical Sciences held at EJUS ISAR in 2017. She also have been awarded with the Best Session Chair Award in International Innovative Research in Science, Technology and Management in 2017. She has got a Best Paper Award in National Conference NCET MMS in 2015, organized by Calcutta Mathematics. IMS Award in the year 2014 for presenting Best Research Paper. Then Chhattisgarh Young Scientist Award in Mathematics. Then Young Dynamic Research Scholar Award in National Conference in kinship between Mathematical Science and Society, organized by Government GYT College, PG College, Durg. Madam has also secured a gold medal for securing highest marks in the subject of science MSc examination by Pandit Ravi Shankar Shukla University, Raipur. So we are very overwhelmed, ma'am, to have you with us in this session. Thank you, ma'am, and please enlighten us with your knowledge. Thank you.
Okay, thank you so much, sir. So now I'm going to share first my slide. Yeah, is it visible? That PDF? That PDF actually I have shared, genetic algorithm for modeling and optimization.
Yes, madam. Yes, madam. It is visible.
Okay, so as I have seen your schedule, okay, shared by Vadma sir. So there I have seen that this program is on basically on optimization technique, multi-objective optimization techniques. And till date, whatever lecture title I have seen, so I think before focusing on that genetic algorithm, suppose directly I'm coming to that topic, genetic algorithm, then might be it will be difficult for some of you to actually apply for your research purpose, actually direct application purpose, because algorithm. I will start from very basic. How can you do the modeling? Because first question arises where it is applicable, why we are using this genetic algorithm. So I can say simply it is a meta-heuristic algorithm you can use to solve that optimization problems if you have some nonlinear kind of problem, or maybe somewhere this unique solution is not possible. Okay, so you can apply the meta-heuristic algorithm. Then maybe first question arises in your mind, what is heuristic, meta-heuristic, how can we formulate? So once you know about the problem, ki how can we solve or how can we formulate actually. First part is formulation. Okay, if a real world problem is given, suppose I am asking you ki I want to come from Jabalpur to suppose Bhilai, okay, and I want to minimize my time. Suppose I have limited CL and whatever, so I want to minimize my time as well as cost. So this problem is in words. So as a mathematician, as a scientist, or as a people from that engineering background, so first you need all the information about the problem. Okay, first you have to understand what is the actually problem, what type of conditions there. Conditions means constraint. Slowly I will come to the optimization part. How can you relate this real world problem into optimization form? Okay, so I am starting from modeling. So what is model? Model means don't go for that theoretical all this line. I'm not going to explain all these things. Okay, just it is included for your knowledge. Model means whatever real life problem. As I told you, I want to come from Jabalpur to Bhilai, and I want to minimize my total cost as well as my time. And the constraint are that I'm not comfortable to do the journey in night, or maybe I'm not comfortable to come by taxi, something like that. I prefer to rail or air, whatever mode. Okay, so all these are my conditions. So what is my objective function? Before coming to objective function, first we have to think what I want to decide, my decision variables. Suppose a company is producing two type of products, product A and product B. There are two type of machines, okay? Suppose first product will take 1 minute or 2 minutes in manufacturing process in machine 1, and suppose 2-3 minutes in machine 2. Similarly, product B will take some time. Machine is available for the limited time, okay? And I want to maximize my overall profit. So this is the problem in general. If I'm telling you, write the model, okay, or mathematical model for that problem. So slowly I will come to that part. How can you formulate the same problem as a mathematical modeling? So modeling means whatever problem is given, okay, we have to describe this into mathematical equation form. There will be some variables, some constraint, parameter. That means, and one thing is most important, whenever you are going to solve or formulate a model, okay, model means basically that mathematical model, because there will be some equations, some terms, whether you are a people from mechanical, EC, computer science, whatever background. Okay, if I'm going to solve a real life problem, then definitely there will be some decision variable, one objective function, more than one objective function may also possible. There will be some constraint. Constraint means simply there will be some conditions. And under this condition, you have to optimize your objective function. That means your criteria function or whatever is your final objective. Okay, either I want to maximize my profit, minimize my time, whatever. So if you are going for the modeling, so most important thing is understanding of the engineering system. Whatever problem is given, first you have to understand this one. Okay, so this may be by observation, by experiment. If it is something experimental kind, so you may check that literature survey, okay, that kind of things happen. So the data varies between this to this. Okay, these are the parameters. Or maybe if it is a direct problem, so first you have to observe, think. Okay, for that purpose, I can suggest you first you read the problem again and again until and unless you understand actually what is the problem. Okay, and this should be very simple. Research, because all of we are doing the research. So research means research. Again and again you have to search until and unless you will get actually what is the problem. Not like that your model is very complex, so many functions, so many your constraints, then that will be totally useless. Okay, you can say that, because if your model is easy to use, then definitely for real life application purpose, people will definitely follow or use your that technique, whatever technique you will produce or you will propose in your research papers or maybe in some project, whatever you are doing. So computer are the great tools. However, the most important thing, without fundamental understanding of engineering problems, this all will be useless. If you do not know exactly which kind of optimization problem or where this genetic algorithm or PSO particle form optimization or whatever heuristic, meta heuristic, classical techniques are applicable, then suppose randomly if you are going to add this algorithm, then that will be totally useless and wastage of your time. So first, this should be very clear and you should first read your problem. Okay, this is the problem. Then you have to do the classification. Okay, under this optimization problem, that whatever problem you have, that is you can categorize in this category. Okay, you can classify. So after finding the classification, then you have to go for the appropriate optimization technique, and a genetic algorithm is one of them. Okay, so once you in brief, actually graphically you can understand whatever real world problem, as I told you, the problem of that two type of product you are going to produce, okay, and this machine and all these things. So whatever real world problem is given, first you have to simplify. Simplify this. This is applicable for any type of problem, whatever problem you have. Okay, first you have to simplify this into a working model. Working model means it is not a something technically actually word, it is not a technical word. Working model means something rough idea. If I'm telling you, okay, there are two machines, two products, these are the conditions. So that is okay for the common layman. Okay, once they have communicated their problem to you, then as a researcher, you have to think. First, you may either you can put some graphical way or some tabular form, so that this actual problem will be roughly you can draft. Okay, that is the problem. And then you have to represent this whatever the working model rough draft you have prepared. You have to present one mathematical model. Mathematical model means what is your objective, what are the conditions. Always be careful whenever we are going to formulate a problem. okay, formulate a problem in some modeling form, then be careful, all the conditions, whatever restriction, all this should be formulated properly, because computer has no brain. Okay, whatever you are giving in coding, that computer will produce you the output. That may be garbage also. Okay, so whatever that coding you are doing, that is the most important part. How can you do the good correct coding? If you have good knowledge of the fundamental this mathematical modeling. If your model is correct, then definitely you have to choose the that better or whatever is option optimization technique fit for your problem. Then you have to choose, okay, this proper algorithm is good for my model. Then you will come to the point of coding part, this computational part. Once you do that computational part, then you have to check the simulation validity, whether it is valid or not. Okay, then interpretation, if it is acceptable or not, then only your process will be completed. So in my talk, first I will try to start from very basic example. Okay, how can you do the modeling? Then I will come to the part of genetic algorithm. I will try to explain all these topics or all this area in very simple way. Okay, and some notes also I will share at the end of my presentation. After my presentation, actually, I will give you that notes also. So whatever your problem, first task is that identify the real world problem. Okay, once we have identified, then second term, represent your model in mathematical model form. Okay, this thing is most important. The success of a mathematical model depends on how easy it is to use and how accurately it is. So as simple as possible, we have to formulate our model. That means our problem. Okay. Then whatever mathematical you have done, you have to convert this into some computational form. Why I am asking about the computational model? Like in my talk, first I will give you one example that is very simple and manually you can solve. Only two variables, like two machine and two products. So okay, I can solve manually. But suppose if you are going for the real life problem in some company, as you, most of you are from mechanical background, if you are doing manufacturing something, or supply chain management if you are handling, then there will be the data constraint, all these things will be very big. Okay, large scale optimization problems. So there it is not possible to solve manually. Okay, so for that purpose, we have to write our coding and this algorithm. So for that algorithm, most important thing, choice of your numerical method, what you are going to choose, okay, and your algorithm software. This is also most important part. Okay, I will give you some MATLAB, C++. There are also Cplex and Lingo. So I will tell you that part later. Then we have to check the simulation part. Simulation means we have to verify whether it is acceptable or not, range of the validity, all these things. Then there will be the conclusion part. So this is our overall work when we are going to formulate a real world problem, okay, into mathematical model form. So now the question is, what is optimization and where it is? Okay, so optimization means even now all of you are doing the optimization. Even I am also doing the optimization. What you are doing, your target is that in next 1 hour 15 minutes, how much you can get the knowledge about the optimization technique or genetic algorithm, about what is that, where it is that. So how you can increase, you can optimize your knowledge during this lecture. Okay, so that it may be useful for your research work or teaching work and whatever. I am doing my optimization key. Okay, I have lots of that material, and how can I summarize and how can I simply explain as much as possible in next 1 hour 15 minutes. Okay, so that is the simply optimization when I am going from, if I am planning to come visit my home, then also I am doing the optimization about my time, about my cost, okay, and my convenience, all these things. So everywhere, whenever there are some conditions, okay, under some conditions, you want to find the best solution. That is your optimization. Okay, so optimization is everywhere. So what is your goal? Under the given condition, find the best one. Okay, to find this one, actually to search the solution, there are several methods available in optimization. Okay, so we have to first find which one is good and appropriate for us. So what we need to apply the optimization, first we have to do the modeling part, okay, your mathematical modeling, and second thing, your algorithm, okay. So algorithm should have robustness, that means good performance for a wide class of problem, not for a particular specific problem, okay. If it is applicable for the wide class of problem, then definitely whatever research paper you are going to publish, or suppose you are working in some project work with tie up with some companies or whatever, Then if the range of applicability is wide, then definitely you will get the good chance, okay? Or you can publish your paper in good journal. Efficiency is also important and accuracy. Okay, whenever we are talking about the heuristic and meta heuristic, nobody can till date say that if whatever algorithm he and she has proposed, that is the best one and that is unique. No, there is always a possibility to find the better one. That's why I am again and again asking you, fundamental knowledge of this optimization technique is most important before applying any kind of heuristic algorithm. Okay, that then only you can save your time and all these things. Okay. So what is the actually flow chart? You can see that you need for whatever you what you have to do for your optimization. Need of for optimization. Okay, first I have to check. Choose the design variable. Actually, term is different, so don't worry about that. This design variable, or in mathematics we are saying decision variable. That means what I have to decide. Formulate the constraint. That means constraint means whatever condition. Okay, this machine is available only for 3 hours. Okay, if suppose I am going from Jabalpur to Delhi, so only 3 airlines are available. That for the flight actually Indigo suppose is SpiceJet, Air India. So only 3 options. So all these things are your constraints. So whatever modeling you have to do, all the condition if you put appropriately in your model, then whatever output you will get finally, that will be the, no doubt, that will be the good, or you can say that that will be the best option, that best solution. Okay, so under the condition is given, then you have to formulate your objective function. Okay, and then select the set up your variable, set up your variable bound. If there is any bound between these two days or something like that, lower bound, upper bound, then algorithm you have to apply and obtain the solution. In between there are also many processes, but I have highlighted the main broad area. Okay, that we will do, don't worry, during this talk, so that you will get some idea. So classification of optimization method. So we have to check, we have to classify whether it is single variable, multi-variable, constraint, unconstrained, single objective or multi-objective. Most important thing, whether it is linear or non-linear. If your real life problem or whatever formulation you have done, that mathematical modeling, it has some non-linear terms. Okay, that means maybe your objective function, maybe some constraint, or maybe all are non-linear. Then you have to apply this non-linear programming problem, that technique. Please remember that whenever we are going to solve a real life problem, definitely there will be some non-linear terms, because simply you can see in your nature actually everything that is not linear. Okay, with respect to time, that weather changes, okay, randomly. Okay, you cannot say that if I'm going to plot the graph, then this will be line. Definitely it is non-linear. So when we are going to solve this non-linear programming problem, or in a simple way, your modeling has some non-linear terms. Okay, then maybe your decision variable, maybe some decision variable are integers. Why integer? Just think by yourself. Okay, whenever I am telling you something or you are reading somewhere something, just ask from yourself why I am learning this, where it is applicable. Suppose I can replace this one by that one, then what will happen? If you ask this question by yourself, then definitely this will improve your knowledge, fundamental knowledge. Okay. So if I'm telling you it is non-linear and maybe some variable, design variable or decision variable are non-integer, what it means? If I'm telling you some variables are integer, means like how much quantity of product A and product B I should produce so that I will get the maximum profit. Okay, in my company, suppose I am a manufacturer. Okay, and suppose these products are table and chair, then definitely your decision variable should be integer, because you cannot say that finally you can manufacture 1.2 table or 2.3 chairs to get the maximum profit. Not like that. This should be integer. So be careful, if whatever modeling you have done, if it is non-linear, some variable are integers, some may be definitely your the real number, because if your cost is there, then cost is in rupees, so that may be decimal value. Okay. So if some variables are integers, some are real, that means it is a mixed integer non-linear programming problem. So till date, it is very not difficult, but if you are handling really one real life problem, okay, with big data, then it is difficult, not difficult, but it is challenging to find the best solution. Mixed integer non-linear programming problems. For that purpose, actually, we are using now that heuristic algorithm and meta heuristic. Meta heuristic means upper level of heuristic algorithm. Nowadays, that PSO, column generation, okay, that cuckoo search, genetic algorithm, all these things people are using in some generalized form. So all these are your heuristic algorithms. So this already we have done. Okay. Earlier I have explained you one example. Suppose you have two type of product, two type of machine. There are some limitations. Per unit profit also given. As a suppose company owner, I have given you the problem कि I want to maximize my overall profit. So please formulate the problem or not formulate. As a company owner, I will only tell you if I have this problem, please give me the solution. What is best solution to get maximum profit? Then now, as a mathematician or as an engineer, what is your work first? To draft a rough, as I told you earlier, a working model you have to produce. Okay, you have to design. So what is the problem? In words, the problem is given. You have two type of that company is manufacturing two type of product, type A and type B. Okay, there are two type of machine one and machine 2. Okay, and this product A, one unit of product A will take 2 minutes for manufacturing in machine 1 and 1 minute in machine 2. 1 unit of this type B product will take 1 minute in machine 1 and 3 minutes in machine 2. Machine 1 is available for 3 hours and 180 minutes and machine 2 is available for 300 minutes per day. Okay, and that is the profit. All this information is given by that company owner, whatever person is given you. Okay, per unit that profit is $1 and here $1.2. Now what is his problem? How much quantity of this product A and product B he should manufacture so that he will get the maximum profit. Now, as a researcher, as a mathematician, you are going to solve this problem. So this is one kind of optimization problem. So first I have that prepare one rough draft, okay, your working model. Now I am going to convert this into a mathematical model form. So first question, what I have to decide? So I have to decide how much quantity of product A and product B to be made so that I will get the maximum profit. So suppose there are two variables x, y, x1, x2, whatever you want to, you can write x be the number of type A product and this y is the total number of type B product. Okay, so x and y we have to decide total number of this product A and total number of product B. So x, y, two decision variable. Now, what is your objective function? My objective is that to maximize overall profit. Okay, if the total number of product A, okay, the total number of product A you have to make it is suppose X and the total number of product B is Y, total quantity. So per unit profit is here $1 for type A product and per unit profit of this is $1.2. Okay, so what is your profit function? Your profit function will be here. Per unit is 1, total X. So 1 into X plus per unit here profit is $1.2 and total number Y. So profit function will be your X plus 1.2 Y. Now what is your objective? To maximize this function. What is P? P means P is a function of your X and Y actually. This is the X and Y. So X and Y are your decision variable. So what is your first task you have done? Decision variable. Second is your objective function. So we found our objective function. So this is my objective function. Now, what conditions are given? So that will be your constraint. Okay. So constraint means here, this machine 1 type A product is taking 2 minutes. Okay, for manufacturing of 1 unit of this type A product in machine 1 and in machine 2 it is 1 minute. This machine is available, M1 is available for 180 minutes. So total here X, here Y. So 2X plus Y should be less than or equals to 180 because machine is available only for 180 minutes, not more than 180 minutes. So here your problem is this 2X plus Y, this should be less than equals to 180. Okay. Second constraint, here we can see that X plus 3Y less than equals to 300. Second constraint. Okay. And there is one important non-negativity restriction. Non-negativity means X is the total number of product A, Y is the total number of product B. Definitely this X or Y should be greater than equals to 0. Why greater than equals to 0? We cannot say that you can produce -5 chairs or -50 tables. Okay, not like that. This should be positive. Okay. So non-negativity restriction is the last one. So this condition. So now what is your model finally? You have seen the problem in simply word. Whatever he has said, okay, in my company this is this type of problem. I want to maximize my profit. Then you have prepared one rough draft. Now you have prepared the mathematical modeling. So mathematical model is your what? That model is, I think that slide, okay, no problem. So that is your model actually. You want to maximize your profit. This is your objective function, okay, and these are your set of constants. 2x plus y less than equals to 180, x plus 3y less than equals to 300, x and y greater than equals to 0. So this is your mathematical model. Now you have to think about the solution approach. Solution approach means first you have to classify the problem. So here whatever you have formulated, you can see that your objective function x plus 1.2y linear constraint, all constraint, these two constraint are there with two variables. So linear and non-negativity restriction. So this mathematical modeling is your linear programming problem. All are linear, it is not non-linear. Two variable. If it is a two variable linear problem, then just recall whatever you have learned in your BTech or BSc MSc classes. So we have seen in operations research we can solve this by using graphical method or by using simplex method. We know that part, okay? I suppose that you know because that is a very fundamental basic thing. Okay, so linear programming, how can we solve? By using with two variables. If it is with two variables, simply graphical method. So here you can see that we have simply plotted the graph, okay, for this constraint, second constraint, okay, and then this is your feasible reason, okay. So feasible reason, so where your optimum value is at corners, so at corner point, so you have to calculate the value at the corner point for getting the feasible means at this region, in this region, this whatever point you will take, or this ABCD region here, any point you will take, all this point will satisfy the constraints. Okay, constraint means that two constraint is given and non-negativity restriction. Non-negativity means you have to consider your graph in this positive actually this side because x and y both are greater than equals to 0. So this is your feasible reason. Now which one is optimum? So at each corner point, these are the corner points. I have to calculate the value of the objective function. Once we calculate, so here we get, yes, this is the optimum value. So what is your solution? Your solution is that total number of product A should be 48 and this should be 84 so that you will get the maximum profit. Okay, so that is the answer as a scientist or mathematician you have to give to that company owner. Okay, so this is overall in very brief or in simple way I have explained you how can you formulate a real life problem as a mathematical model form. Then what method is appropriate or applicable here, and by applying this method you have to find the solution. So since it is a very simple problem, okay, so that we have solved this manually. But if that data is big, okay, number of constraints are 3, 4, or maybe your decision variable are 5, 6, okay, and some constraints are non-linear, then we have to think about some appropriate optimization technique. Okay, so now slowly we are coming to that optimization techniques. So till this slide we have learned that suppose this is the optimizer, okay. So as an optimizer, you have to find the solution. Some problem is given. So what is required here? First, you have to find your decision variable. We have seen in the last example what we have to decide. Design variable, your constraint, what type of condition is given, your objective function. Okay, this is my objective. Okay. And then after getting all these things, like in last example, we have seen, okay, this is my objective function, then these are the condition. Then you have to check your solver. In last example, the problem was linear programming. Linear programming, since that was only with two variables. So simply I have applied this graphical method and manually we got the solution. Even you can find the solution by using MATLAB, that same problem within that 30 seconds. Since only you have to put your command, that decision variable and inequalities, you will get the answer. Okay. So first we have to check according to classification of this problem whether it is linear, non-linear, mixed integer linear programming. That means overall programming that model is linear, but some decision variable should be integer. So that will be mixed integer linear programming. And this is your mixed integer non-linear programming. Mixed integer, earlier I told you, okay. So till then, this is a difficult part you have to handle because there are some integers, some real number. Programming is already non-linear, okay. So in that case, we have to find the optimum value of the problem. So once all of these things you have, so as a optimizer, I have to check this solver is applicable. Then most important thing, you have to put your data also, whatever data. Like in last example, if it is given, there are two type of product, two machine, and this is the condition ki machine is available for only 300 minutes, 180 minutes, whatever. So this is your data. Now the most important thing, how much experience you have. Okay, if you have the fundamental knowledge of this optimization technique and already this type of problem you have handled, okay, so definitely you may choose the appropriate and best one, that optimization technique for your given problem. Then whatever answer you will give, that answer should be, this is most important, this should be feasible. Okay, feasible means this should satisfy all the constraint. Okay, this should be optimal also. That means whatever solution you are getting, that will optimize your objective function. This should be high quality. Obviously, the quality should be high. That is important. Low cost. Cost should be low. One thing here I have not mentioned. This should be as simple as possible. Okay. So that is your overall task as a mathematical optimizer or as a from engineering background, no problem. Whatever problem, as I told you, whenever you have some restriction and you are looking for the best solution, this is one optimization problem. Okay. Then whatever problem, according to your problem, you have to first do the classification. Once you find the classification in that particular area your problem arises, so according to classification, you have to choose appropriate method. Okay, and whatever you are getting, that should be as simple, and whatever actually formulation you are doing, that should be very much simple, because time is most important. If unnecessary, suppose you have added that 3, 4 or more than 5, 6 constraints, but maybe same formulation I can do with including only 2 constraints. Maybe you have added 10 or 12 decision variable, but suppose I can, same problem I can handle with a model with only 4 decision variables, then definitely whatever model I will design, that will produce a solution very quickly compared to your model. So in that case, that comparison is most important thing. Whenever you are going to submit some research paper, okay, where you are doing some optimization part, then one question always arises: highlight the applicability of or applications of your research paper, significance, and suppose you can give some comparison. Okay, comparison means most important thing, your comparison with not in some earlier very simple kind of paper, in some referred journal you have taken 2, 3 papers and you have, suppose you are giving the comparison with that paper. No. If you are trying to publish your paper in good FCI journals, okay, then whatever comparison you are giving with your result and the earlier published paper result. So whatever paper you are going to cite, that should also be published in some good journals. Then only your paper will be, there will be chance to publish your paper in good high or in high impact journals. Okay. So once your problem may be anything. Okay. Here I have highlighted only few problems: the production planning, sequencing, manpower, maybe scheduling type of or resource allocation problem. So everywhere you have to first check the classification of your problem, and accordingly we will apply the appropriate optimization technique. So in that graph I have highlighted some of these problems. So slowly, one minute, I will increase the size so that you will get some idea. So whatever problem, that real world problem you have, suppose you have formulated this, then you have to check which technique is applicable. If that problem is non-linear, so definitely you will go here to apply the non-linear technique. If your problem has some integer, okay, yes, decision variable is integer, then you have to apply the integer programming. If there are some modern method, this I will come to later on that part. If it is linear, then you have to apply this type of method. And there are some classical techniques. If you remember in our BTech classes, okay, we are teaching to our students, or we then how can we find the maxima, minima, single variable, 2 variable, all these things. So classical techniques nowadays, if I am talking about the real life problem, this classical technique is not applicable. Why not applicable? Because here the differentiability, continuity, it is one required field. Okay, like if you plot the graph of mod x, okay, so mod x, you can check that at x is equal to 0, this function is not differentiable. That means this classical technique say that there is maxima, minima, that means extrema not exist. But we know that this is the minimum point. Okay, because it is not differentiable. It is continuous but not differentiable at 0, but still there is a minima exist here. So everywhere we cannot apply the classical techniques. So suppose it is linear programming, then we think about the simplex, dual simplex, transportation, all these things. Even the simplex method you cannot solve manually. Suppose there are so many constraints, it will take more and more time, and there may be possibility of doing errors. Okay, so for in that purpose, you can write simply the code. But yeah, in MATLAB, Mathematica, inbuilt that programming is given. Now, what is challenge for you? Suppose whatever problem you have taken for your research work, okay, definitely there will be some non-linear terms. If it is not a hypothetical example, okay, if it is non-linear, that means it will come under this category, non-linear programming problem. So that numerical methods you have learned like that constraint, unconstrained, KKT condition, Kalish-Kuntakar. So I'm not going to highlight that part. Okay. In that case, if it is non-linear, maybe some integers, then no one can claim that the unique solution exists. This optimum solution will be unique. No, there may be possibility. The best solution may be possible. But you just think about that. If the problem arises suddenly, okay, like airlines disruption management, suppose a flight is delayed by 2 hours, okay, after 2 hours, suppose it will reach from suppose Delhi to Mumbai flights, so it suppose it is reaching to Mumbai, okay, so to landing the flight, so before 2 hours, suppose I have assigned this runway, okay, that belt number, that gate number, and some group of people to handle the baggage and to handle the contact passengers, all these things. So definitely if the flight is delayed by 2 hours, so after 2 hours, same thing I have to arrange for that particular flight. But you think if it is Delhi airport, if I'm talking about the international airport, Delhi, so after 2 hours, definitely the same runway, same group of people, that belt number and that staff all will be assigned to handle some another flight. So now the problem is that since my flight is in the sky and that have to land, okay, so how can I arrange or how can I allocate all these resources to that particular flight within 1 hour or within 15 minutes, within 30 minutes, I have to decide. So in that case, solution is required. So you cannot say that if you are not able to give me unique solutions, so I am not going to use your technique because nothing is that something is better than nothing because I need something. I have to finally give my input. Okay, that flight have to land. Okay, so in that case, you are very much interested to find the best solution. Okay, whatever in what capacity you can do the best one. What is the option? Okay, then best you will choose. So that is actually heuristic algorithm where it is not possible or you are not sure okay, whatever you are getting that is the optimum. But yes, it is near to optimum or somewhere you can use the word approximate solution, okay, approximate to your optimal solution. So for that purpose we are using this heuristic algorithms. So meta heuristic means there is whatever problem you are handling, some higher level of heuristic. Same heuristic, that is not the unique solution, but some more techniques we are applying to search the solution. So this technique, some other techniques here, dynamic programming, stochastic programming is available here. Okay. So here this genetic algorithm is in the modern method. This one algorithm is your genetic algorithm. These all particle swarm and colony optimization. These all are actually nature inspired. Okay, in nature, we can see that if a group of birds, okay, they are searching for their food. Okay, so how they search? Because they are not a human being, they do not have that capacity of mind like us. Okay, but how they can search? That aren't how can they find their food, making a chain and all these things. So our target is what? If you have this number of possibilities here, okay, solution is somewhere here. Maybe this is the solution. Okay, but you do not know here is the solution. Okay, so how can you start? This is a physical reason. How can you start? Okay, I have to make, like in last example, how much quantity or number of table and chair that company should produce so that it will get the maximum profit. So in that case, they know that maybe per day they can make this 100 table or maybe they can make 80 chairs like this. But what is the exact solution? So overall, this all possibility, they have to find this one is optimum. So what this heuristic algorithm is doing, all this heuristic meta-heuristic algorithm or whatever optimization technique you are applying, search method, they are searching for the solution. So how can you search? Suppose you are in a forest, okay, and you are searching for one space. So how can you go to that particular space in a forest? There is no road or something, you do not know anything. So first you have to find the direction, in which direction I have to go. Direction as well as you have to find the step length. Okay, up to 500 meter I will go to this direction, then I will take this turn, then I will come here like this. So your search space, you have to go to that point. That is your actually final solution. So maybe you can find or you can come to that point by looking this way. Okay, you can say this is very lengthy. Okay, maybe you can search to this, and finally you are here. And maybe someone come directly here to here. Okay, so all these are the way I am showing you. This is your optimization technique, that meta-heuristic algorithm you are using. Now, how much appropriately you are applying your technique, this decides length of your path. Maybe unnecessary, some algorithm will run here to here, here to here, here to here, and then maybe after 3-4 days, 5 days, and maybe you will stuck somewhere and you will not get the final solution. So that's why I'm telling you, whatever method, every method, with all these methods, PSO, whatever you are applying, nature-inspired algorithm, the target is that this is the problem. Here is my solution. I have to solve. Now, all these techniques are providing you how can you go from this direction up to this step length, and how can you reach up to this solution. Okay, so that is your target. So this genetic algorithm is one way to find this one. Okay, so after this, so next slide, heuristic. So what is heuristic means? I can decrease the size so that you can see here the entire material. Okay, so heuristic algorithm actually provide a shortcut to solve the difficult problem. Okay, this used under limited time, or suppose you have limited number of people, like in the case of this airline disruption management, suppose this flight is delayed by 2 hours, so definitely your time is limited. Within 30 minutes, within 1 hour, I have to decide which runway will be assigned to that particular aircraft, okay, which gate, that arrival gate, all these things we have to assign. So shortcut way to find the solution, immediate solution, definitely that will not be the your actually optimum solution. So this technique is problem dependent, that is the most important. As I told you earlier, depending on your problem, you have to choose which technique is more appropriate. Okay. So heuristic are good when you have limited number of time, limited number of information, okay. And decision is not that important. It means that a decision is not like that if you are doing something or if you are taking the decision related to something in defense or like this, or in some company where you need the unique solution. There you cannot apply this method because you have to, so that your problem, you should clear the problem. What, in which problem you are going to apply this. Okay. So heuristics are bad when having plenty of time and information to make important decisions. Okay, if you have sufficient time, information, then don't go for this heuristic algorithm. Unnecessary, why you are going for that if it is not optimum, it is near to optimum. In that case, if you have sufficient time, sufficient information, go for the unique solution, go for the optimum one, which is the optimum. Okay, so there are many examples of this heuristic, that techniques, and yes, meta-heuristic. Meta-heuristic means, meta word means it is an upper level to find this. Okay, that means same way you are following that heuristic algorithm term, but in some higher level way. Higher level way means intelligently you are thinking about this, exploring, exploiting. That means if that is your reason, there is the solution. Okay, I have to find the path. Okay, so how much intelligently you can find this one. So if you do this heuristic on some upper layer, okay, find the efficiency of this, then this is your meta-heuristic kind of algorithm. So whatever we are doing till date, that is your meta-heuristic algorithm. Okay, this nature-inspired algorithm actually. So maybe there is some more talks after that I have seen in your timetable. So you may get some more ideas about that. So fundamental properties of this meta-heuristic means, meta-heuristic are the strategies that guide the search process to avoid being trapped in some confined area. What is the meaning of trapped actually? That I will come to later, okay? In that, by one graph, I will show you what it means. So this goal is to efficiently explore the search space in order to find the near optimal solution. As I told you earlier, we cannot say that it is optimal, but it is near optimal, approximate optimal solution. Okay, and this meta-heuristic algorithms are approximate and just wait. Okay, beta. Okay, so I will finish actually my talk by 3:55 because I have to join another meeting. Okay, that's a different part. So the goal is to efficiently explore this search space in order to find the near optimal solution. Okay, so these algorithms are actually approximate and non-deterministic. Also, it is not problem specific. Problem to problem, your technique may be different. Now, what is your genetic algorithm? So genetic algorithm, or you can say that it is the evolutionary algorithm. Okay, so this is some that literature review part that I will share with you, so don't worry about that. So there is the history behind that. In this year, that will then year by year people have generalized the result. Okay, there are taboo search method and colony optimization, PSO, You may heard that honeybee problem. So all this actually firefly. So actually all these problems are inspired by the nature, and basic behind all this technique is that how can you search the optimum value near optimum value. So this all are meta-heuristic. So what is the actually in differential evaluation? That is the basic. First you have to initialize the vector. Then you have to evaluate the fitness. What it means I will explain you later. Then you have to select. Then mutation process. So at this time skip this one. One by one I will come to that part. So all these are your heuristic algorithms, cuckoo search, firefly. One thing is most important. Once you understand how we have to do the mathematical modeling, most important thing, whatever problem is given, first read it again and again until and unless you can simplify the problem. Simplify means whatever problem is given, you are able to explain your problem to a common layman, those who do not have any knowledge of science or mathematics, whatever. Okay, so very simple form. First you have to understand the problem. Once you understand the problem, you have to formulate your mathematical modeling. Once modeling is done, then you have to classify the modeling. Classification, in which category the problem comes. According to the classification, you have to choose the optimization technique. According to your optimization technique, you have to choose which software is appropriate, okay, whether it is applicable to C, C++. There is another actually to solve this, large scale optimization problem. Actually, I am using this one, this Cplex also. If your problem is very simple, then you can solve this by using MATLAB. Okay, no problem. By using MATLAB or Mathematica, okay, or Mapper, you can simply solve. If it is a large scale optimization problem, data is very big. So definitely if you apply your MATLAB or you will write the coding or algorithm in MATLAB, after some time or maybe after few hours, you will get nothing. So Cplex is one software you can use. This is the combination of C language and simplex method. C language, we know that C language, and simplex method means that operations research to solve this linear programming problem. So simplex is good if you have a big data. Big data means suppose you are constrained in lakhs, okay, and decision variables are in 1,000, 80,000, 70,000. Now you think that how your constraint may be in lakhs or 50,000, 40,000. How? When you are writing your code, okay, suppose you have plotted one loop, from I is equals to 1 to 10,000, up to 10,000 iteration it will run. Okay, so you think about your computational time. That time is most important, whether your algorithm is polynomial time bound or not. If it is giving the appropriate solution within given time, then it is okay. Otherwise, it is not. It will produce whatever that garbage value, or maybe you are getting the solution after the limited time. Maybe your time period will be over. Okay, so this Cplex is one software. Another one I can suggest you can use this Lingo. Lingo is very good actually. That free option is also free, that license also available, but for few days. Okay, this Lingo. But if you want that full to use that Lingo with full properties, that means large scale optimization problem, then you have to purchase the license. Otherwise, I can recommend you simply you can find this Lingo freely from Google. Cplex is okay. Cplex you can find. For that Cplex, you have to register your email ID, your institutional email ID as a faculty or as a student. Okay, you can write, and freely they will provide you one link and you can use this Cplex. Okay, that tutorial, how can you understand this language? No need to attend any trainings or this program. Okay, you can simply type that Cplex on your YouTube. You may find some lectures, or in Cplex, once you download in your computer or laptop, okay, you will get this, that here there is one tutorial file, okay, and tutorial PPT. And there are also the good thing in Cplex, there are lots of, I think more than 100 inbuilt example is given. So that code and everything is given problem, so you can do the practice by yourself. Lingo, same thing you can apply. If you have some simple problem, then you can use MATLAB. MATLAB is okay. Mathematica is more user friendly because most of the terms or functions are given inbuilt, that linear programming, all these things. MATLAB is also okay. Maple, that another Maple you can also use. So that MATLAB, Maple, Mathematica, all these things which is appropriate for you, that depends on your problem, on which problem you are working. Accordingly, you have to apply your that software. Once you've done your coding on that particular software, you will get the output. Then once you get your output, you have to check whether it is valid or not, okay, applicable or not. So that is finally done. So up to this you have to do. So you have started from real world problem and up to this you have to reach. So then only you can say that yes, actually you are applying some optimization technique. Okay. So these are some search methods. Search method means then you have the feasible reason, you have to search your solution. Already I have explained you one graph, so that is same thing. Calculus based techniques or your random search technique. Random search, I will come to that part later. And there are also some enumerative techniques are there. Okay. So your genetic algorithm actually comes here, evolutionary, because it is inspired with the nature. Okay. So actually generation by generation, how can we improve? So by inspiring that fact, suppose there is a suppose that giraffe actually. So if you see generation by generation, their neck, actual length of neck is increasing. In next generation, it is better, better, and better. So inspired by this one, if I'm searching my solution, and in each next step, I'm getting something better. In next, more better, more better. Then finally, definitely, whenever I'm reaching to final iteration or when I have to stop my that algorithm, I will get the best one. So this is inspired by this one. So algorithm, this genetic algorithm comes here. Till date, people are working on that genetic algorithm, or there are so many generalization actually. Till date, they are doing something collections. So the best, the main thing is that select the best and discard the rest. So which one is best? You have to select and just ignore the others. What is the that inspiration behind this? You can see that the giraffe have long necks. Okay, if you see that earlier their species, then comparison to them, their this neck is length is increasing next generation by generation. So what is the need actually? That was the reason if they are longer, they have these long neck, then definitely they could feed on leaf of higher branches. Okay, so suppose when all the lower one had been eaten by some other, then in that case they can survive. To survive, they may think like this. So inspired by this actually, or they thought that evolution means evolution is the change in the inherited traits of the population from one generation to the next. So here this generation, gene, chromosome, all these words will be used. But don't worry, that is not biology actually. Okay, so this is only for inspiration purpose. But I will explain this with mathematical terms so that you will get some idea. Now next again I am going to take one very simple example so that you will get some idea. Okay. So we can start. So natural selection leading to better and better species. So that is our process. Actually, this is my search area. Okay, and this is my solution. So this is my first step. Suppose I have to go in this direction up to this length, then up to this step length, and here this actually. Okay, this. So in each step, next, then this is next. So this algorithm ensure that this step is better than earlier one. This is better than earlier one. If suppose there are three options, this one. Okay. If it is not good, so we can discard, and I will choose this one. Okay. So choose the best one, discard the others, and in this way, I will finally reach to my solution or near to optimal solution. So slowly I will explain you what it means. So what is evolutionary computation? Evolutionary means a technique borrowed from the theory of biological evolution. Okay. So that we use to create the optimization procedure or methodology, and usually we implement this on the computer. That means as I explained you earlier. Okay. So we are coming to slowly. That already I have explained you. So this is inspired from that theory. Okay, Darwin's theory. So motivation is that suppose it is not fine to derivatives at each point, okay, gradient based method is not applicable, then or suppose it is difficult to find that, then in that case we motivate to find the solution applying genetic algorithm. This will be good enough, okay, and that process will be fast. So here we have to use some terms. Okay, this is search based optimization technique. Okay, so genetic, natural selection, all these things will be there. So I am skipping this part. Directly I am coming to the mathematics part so that, yeah, where it is applicable. So you may heard that everywhere that genetic algorithm is, but when first time I heard that word genetic algorithm, I thought that, oh, I'm not from biology background, so maybe it is difficult for me to understand it, but that is absolutely wrong thing. Okay, it is very simple genetic algorithm. Only these terms are used to relate that thing. Okay, otherwise there is everywhere is mathematics is there. So first your population initialization means whatever problem is given, okay, that you have to decide. Then fitness assignment. Fitness means whether this is fit for the next step or not. If it is not fit, actually initially you have to assume something, initialization vector. Okay, randomly you have to choose something. Then when you write your code also, so first you have to give some initial value. Most important thing here, you may think that how we can select the random value or the initial value. So that is based on your earlier experience and how much knowledge you have. Okay. In computer, the good thing is that when you are going to write the code in C++ or Lingo, so randomly it will select any vector. There are multi-search option also. I will tell you later. So your target is that how much you can say that how much you can do to find the best solution, whatever in what capacity. It is multi-search or whatever option you can give to your coding, so that finally whatever you will get, there is a 100% chance, but 99% chance whatever you are getting is near to optimal. Okay, so fitness, selection, crossover, mutation, survival selection, and this. Those who do not know anything about genetic algorithm, maybe after looking this slide, you can think that oh, there are so many terms. Maybe it is difficult to understand, but it is very much easy. So each iteration in the cycle produce a new generation of chromosome. This chromosome means initially variable what will take. That is, we name it chromosome. I will tell you by the example. The entire set of generations is called a run. Typically, a GH or genetic algorithm runs from 50 to 500 or more generation. And at the end of this run, actually entire process, okay, you will get a highly fit chromosome in the population. Highly fit chromosome means the best solution, okay, depending on your technique, whatever you have given. So that is the important thing. So there are some words actually, basic terminology we use here. Population. Population means your subset of all possible solutions to a given problem, whatever problem is given. So all set of possible solutions. Like in last example, suppose because the machine was available, machine 1 is available for 180 minutes and another one is for 300 minutes. So I know the possibility, the bound. Ki machine 1 may produce one product, okay, or may produce suppose 40 table in a day or 40 pencils, suppose because it was in a minute, something like that. Okay, that is small kind of product. So you that know what kind of solution available. So all possibilities. Chromosome means one such solution to a given problem. The problem is given, one solution I have assumed, okay, this solution may possible. Gene means one element position of the chromosome, like this is one chromosome, I can say that, okay. So here is the gene, one position. Now you may think that here ma'am is writing 0101, so it is simple, meaning whatever problem, real life problem is given, you have to formulate this into mathematical model, like x plus 1.2y. Then we have to write this x and 1.2y, all these things in terms of 0101, okay, because we are going to write this actually coding. Okay, so don't worry, you have to do nothing in your coding. Suppose you are simply applying this GA using MATLAB. But if as a researcher, okay, you want to modify this technique, then you should know about that, how we have to do. So this LD means that is value of the gene. This is to the genotype, phenotype. Genotype means the real life problem, whatever is given, like x plus 2y, 2x plus y less than equals to 3. So this is phenotype. So first we have to convert this phenotype into genotype. That means in the words 0101, like this binary type. Okay. Once you apply in that, so when you are transforming this phenotype to genotype, this is called encoding. And whatever solution you will get, that will be again in the terms of 0101. Okay, so that 0101 means again you have to decode. So this decoding process means when you transform this genotype to phenotype. Okay, so whatever inbuilt today's, there are lots of algorithms inbuilt with particular softwares. Okay, either you can directly use this one if you have limited number of data and all these things. But if you are working, particularly if you are working on this nonlinear programming problem with large scale, big data problem, then you have to think about the change in this genetic algorithm. Okay, otherwise inbuilt algorithm you may find in the MATLAB and other also. But I want to suggest you one thing. If you are trying to solve this by using MATLAB, okay, so in MATLAB, once you install it in your laptop or computer, you just go where it is uploaded or downloaded in your system. So here you can find this basic file where this or code has been written in MATLAB. So you may search that coding also, so that you will get some idea. If you have this fundamental knowledge, then definitely you can relate both of them. Okay, here it is, so this is the chromosome, that is here the gene, that is all these things you may, or here the mutation process crossover is done, okay, in that algorithm. So as an optimizer, if you are like in our institute, some students are working on meta-heuristic techniques. So they are trying to modify this crossover and mutation, that formulation is given. So they are always trying to modify this part. Suppose they can modify and with using their generalized algorithm, and they can compare some earlier good published papers, okay, the result published in some good journals, and they can give the comparison, and their code may be provide the result faster compared to other paper, then that will also be a good research paper. So they can submit it in the same journal, and that may be published in good journal. Okay, so this kind of things actually people are doing. So here I am giving you one simple example, knapsack problem. Okay, so the problem is that suppose you have 4 items A, B, C, D, and these 4 items have different weight. This A, B, C, D, 5, 3, 7, 2, and this has different values. Okay, each item associated with some weight and some values. And this knapsack has a limited capacity. This is up to 12 kg. You can put inside this only up to 12 kg. So the problem is that which item should be kept in the knapsack so that it will maximize the knapsack values. I want to maximize my profit here, this value. Okay, so how much I can put these items inside this knapsack? Here this condition is given, it is up to 12 kg, and items are A, B, C, D, and this has this weight and values, but weight is limited, not more than 12 I can put here. Okay, so now I have to solve this problem. So problem is that which item should be kept in the knapsack so as it will be maximize the knapsack value. So that is my problem. Now I am going to solve this problem by using genetic algorithm. Okay, so if you remember the genetic algorithm, just I am going behind. Yes, this was your target: population initialization, fitness, selection, crossover, mutation, survival selection, and terminate. With written the best one will be you will get. So I am starting from here. So there are 4 items. If there are 4 items, okay, so what you have to decide which item I should kept inside the knapsack. So total item are 4. So 1, 2, 3, 4. So I need a string of 4-bit string. Okay. So string means your chromosome. So chromosome, these 4 bits are requested to represent the chromosome encoding. So your set space, how much values will be there? Because there are 4, so 2 raised to power 4. That means 16. So generation 1 initial population is created randomly. Okay, if you are writing the code by yourself in your PC, it will take, you can put this in your algorithm, ki computer can take randomly this value. So any value it can check. Okay, and to increase the possibility of getting good solution, what people are doing today, they are just repeating this process for more than one random values, or they may give in the loop ki okay, up to this random values we have to check, and within all the provided whatever solution you will get, you have to find the best one. So all possibility they are editing or they are doing in their algorithm. So here the set space is 2 raised to power 4. So initial population is created, and suppose this chromosome is randomly created, C1, C2, C3, C4. Okay, so 4 bit are required because there are 4 items. Now we check first fitness, this fitness assignment. So population initialization is done. Now we are at the stage of fitness of the function. Okay, so I am taking the first chromosome. You just see first chromosome, this we have taken 0, 1, 1, 0. So 0, 1, 1, 0. So that means A 0, B 1, C is taken, D is not taken, this is 0 value. Okay, this represents that the B and C are present. Okay, but A and D are not present. So you just see what will be the value of the knapsack. Here the value of the knapsack, B and C present. So B and C. What is the value here? You can see B and C. 5 plus 10. So value is 15. What is the weight of knapsack? In that case, here it is. The weight of knapsack is given here 3 plus 7, 10. Sorry, this is the weight actually. And value is what? 5 plus 10, 15. Okay, so 10 and 15. What is the condition in knapsack? Total capacity is 12 kg. So here this is 10 kg and value is 15. So you are getting the profit 15 and here the weight is 10. So you can see that it is possible. So this is acceptable. You can accept. Okay. Then next C2. C2 was what? Randomly we have taken 0, 1, 0, 1. That means B and D are present. Okay. A and C absent. So B and D are present. So B and D. What is the value of B and D? 7 plus 5. So 12. Value is 12. Earlier it was 10. And what is the weight? Weight is 5. Good. We have the total 12 capacity. So C2 is also acceptable. Now next one, C3. You can see here, this is C3. C3 is your 1101. So here we check here. There is, I think, there is some, no, there is problem with typo error. You have to calculate, okay, clearly. This is not correct. A, B, D is present. A, B and D is present. So what will be the weight actually? 5 plus 3 plus 2. That will be your weight. That means 10 kg. What will be the value? 12, okay, plus 5 plus 7. So this is your value. 12 plus 5 plus, here it is actually typo error. So it is your 24. There is typo error. Okay. So here the value is 24 and it is 10 kg and total capacity maximum is 12 kg. So it is also acceptable. Now fourth one. So fourth is 1111. Okay. That's C4, fourth chromosome. So here all are present in the knapsack. Then in that case weight will be your value will be 34. Okay. And weight is 17 kg. But we know that this knapsack has the capacity of 12 kg. So this will discard. So we will not accept. So it is discarded. So now we have three options, C1, C2, C3. These three are acceptable. Now we have to choose which one is best. As I told you, in every generation we have to find which one is best. Okay. So for that purpose, there is this Rowlett wheel selection process. Don't be confused by using this name. It is very simple. So in C1, C2, C3, you check what value was highest. So C1, C2, okay, 15, 12 and 24. Which one is highest? C3. So C3, okay, is the highest probability of getting selected in the next generation because it has the high. Actually, we plot this in a wheel selection that total fitness was 51 and this has 15, 12, 24. So we just put that graph which is taking the more part in that actually this circle. So C3, because C3 has the highest value. C3, then which one is highest? Obviously this C1, 15 and then C2. So highest probability is C3 for going in the next generation. After C3, we can choose this C2 and then C1. C4 is discarded. But we need that 4-bit. Okay. 4-bit means 4 options we need. So after this, we can select in generation 2 because C3 has the highest probability of getting, okay, the good solution. So C3 and second one is your C1. So C3, C1, we can choose this two, C3 and C1 and then C3, C2. Okay, because C3 is the highest, the high value C3. With C3, 1 C1, then C2. Okay, so individual of next generation are selected as follows this one. Then what will happen? Now we are going for the crossover process. This is the selection. Okay, then crossover. The next step is crossover means simply. So C3 has the highest that possibility. Okay, after that C1. So crossover operation takes the selected chromosomes for mating and mix the genetic material to produce offspring. That means the next generation. So C3 is your 1101 and C1 was 0110. Okay. Then crossover. That is the one most important point. Here I will tell you how can you do the research part. Crossover means just here it is doing 1 point crossover. So selected randomly anyone here. I have suppose selected this one. So simply you change this 1 as 0 and this 0 as 1. So this is a crossover. Now what people are doing to ensure about the optimum solution, not the 1 point crossover. They are doing multiple point crossover. So randomly it will maybe this point, maybe change this point, maybe change. So there is you can just think that there is always possibility. Now your target is that how you can apply your methods so that there will be high probability of getting the good solution. That will be your target. So this is 1 point crossover. So after this crossover, you can see that this 0 becomes 1 and 1 becomes 0. So there will be 2 offspring. One will be your 1, 1, 0 and this will become 0. So 0, 0, 1, 1 and this will become 1. Okay, so this is offspring your 1, OS1, OS2 in next generation. Okay, after crossover, doing this crossover of these two, C3 and C1 because C3 was most highest, that is the, and then next, this one C1. So OS1, OS2. So in next, what you have to do? That C3 and C1. By C3 and C1, we got this OS1, OS2. Okay, this C3, C2 do not go for the crossover so that it will remain same in the next generation. So with this C3, C1, what you have got? You got this OS1, office pin 1, office pin 2. So this is your generation 3 and C3 and C3. All these are good in terms of whatever calculation we have, and these are the best one. Now again you have to do this crossover mutation, all this process until you will get the final solution. So mutation means what it will do, like this is the chromosome 0110. So mutation means simply you randomly you can choose any gene, okay, and change the position. The 1 will be 0, 0 will be 1. So you just think if you increase this part randomly, okay, then you can increase the possibility. How you can increase the possibility? This mutation is required so that the search algorithm does not necessarily get stuck at a local minima. That is most important thing. Get stuck local minima means like this graph. If you see this graph, okay, if I am asking you find the local minima, 1 minute. If I am asking you find the minima or maxima here, okay, in that graph. So you check if you have written one code, okay, because as I told you, computer has no brains. Suppose it is starting from this point, then what will happen? It will start from here, then code will run. At this point, value will be higher, then slowly value will be decreased. Now, depending on your algorithm, maybe it will get that, okay, suddenly up to this values, the values are decreasing. So it will produce you, this is the solution, maxima value. But we know that it is not the maximum because maxima value is this one. Maybe you have a stronger, you have using some good, more better algorithm optimization. So it may search here again. Then it will increase value. After this, it will get okay, decreasing. Suppose this graph is like this, not like this, like this. Okay, this graph is like that. So maybe you stuck here because now for many values, okay, whatever you have given in your algorithm, this totally depend on your expertise, okay, and your technique, whatever you are using. Maybe this your algorithm will produce. This is the maximum value, but no, it is not because it is the local. Local means if I am asking you okay, within this to this timing, what was the maximum profit? Okay, so this is the maximum, this one. So it is correct, but it is a local solution, not global. If I'm asking you during entire day or whatever, what will the maximum profit? So that is your maximum. So to ensure that whatever algorithm you have applied, it is not stuck here, or somewhere, okay, or maybe this graph is like this. Okay, then how can we ensure that whatever we are getting that is near to this? Now here it is the global maxima. So what people are doing, they can start from one point search randomly. Okay, maybe this point now it is depending on your luck also. If randomly one variable you have chosen one, okay. So maybe you have started from here. So what will happen? Your code will run from here to here. Then it will get the highest value. Then it will run for a longer time because it is a real line R. Okay, so for each and every value it will run. And finally, after that, whatever algorithm you have chosen, it will think that yes, this one is the maximum. You will get this is the answer. But no, that is not the answer. So for that purpose, what people are doing now, instead of this single search, they are applying this multi-search method of optimization method. So again, they may search from here randomly, from here, or maybe from here. Then for this point, maybe this will be the maxima. For this search, if you are starting from here, it will produce this is the maxima. This will produce this is the maxima. So in all these three, finally you will get yes, this is the maxima. But again, there is a drawback. Maybe your algorithm is stuck here. Suppose you have not chosen this point, you have chosen this point. So you will get only this 3, 1, 2, and 3. Again, you are very far from the optimum value. So in that case, actually, we have to think which one is appropriate. So now you just think that to search the solution, there are many options. Okay. So whatever capacity, in what capacity you can generalize your concept, or you can very carefully or in very intelligently, how can you apply the method to get the solution? So this is the mutation process actually. Mutation means randomly it will select a gene and change the position. So this algorithm will run until and unless you will get the near optimal solution or whatever. So that is in brief, you can understand the fundamental of the genetic algorithm. If you are going to search this algorithm, comparing this method with your traditional method, so this is your actually GA search. GA, the genetic algorithm, search a population of points in parallel, not a single point. Okay, for a 0, 1, any point they can change. Okay, these do not require the derivative information. One thing I want to here highlight, if you have the derivative information, then it is good if you can apply here in other methods. Don't go for this heuristic algorithm. Okay. So as much as paper you will read and methods and techniques, then you will be able to find which one is best for your particular problem. Okay. Regarding coding, I can give you some idea. It is a very general, in general, the genetic algorithm. First, you have to begin. You will begin with time at t is equal to 0. This is your initialization population at t is equal to 0. Then, while not finished, you have to do begin. You have to do here all these things. Your crossover mutation, all this formulation you have to apply. Okay. Then the process will end. This process will end, and then for all entire process will end. So this is a simple code. Actually, I will share one document with your convener. Actually, I will send that document to sir. Within 2 or 3 minutes, I will show you. That is very good actually for to understanding the genetic algorithm. So, what is the advantage of genetic algorithm? Already you have got some idea. It is faster, more efficient. Okay, and this optimize both continuous and discrete that functions. Also for multi-objective function. Multi-objective means in your objective function, like in our example, this was single objective simply. How much quantity of product A, B should produce so that you will get the maximum profit. There may be actually more than one objective. You want to minimize the total cost, minimize the total aircraft or total resources, whatever you are using. So that is the combination. So everywhere it is applicable. But again, I am telling you, first you have to check your problem. Accordingly, you have to apply. GA is not suitable for all problems, especially if it is simple problem and derivative information is available. Fitness value actually we are calculating repeatedly because we are running this code from I is equals to 1 to 10, 1 to 1000, whatever, and again it will check the fitness value. So computationally it will take more and more time. Okay, and since it is a stochastic problems, no guarantee, as I told you by that graph, local maxima, no guarantees, whatever you are getting, this is the optimal. That is only fully depending on the optimizer, what technique he is applying and how carefully it is applying. Okay. So if it is not implemented properly, that is the most important. If it is not implemented properly, then whatever you will get, that will be totally garbage. That means the solution will not converge to the optimal solution. So that is most important thing. These are some references I will share, no problem. And the one thing, is it visible, this genetic algorithm toolbox for use with MATLAB? Is it visible?
Yes, ma'am.
Okay, so I will share this document with all of you. Okay, this is one actually that 94 pages are there in MATLAB. How can we solve? Okay, if you read this thoroughly, whatever I have explained in today's class to you, everything you can understand here. Actually, this actually I have explained in a very simple way. Here you can get some technical also, multi-point crossover. I explained one point. Okay, here then uniform. So all these techniques are used to ensure that you are able to find the optimal solution. Then here this literature, the result, all these things is given. Okay, so you can start from here. Tutorial kind of notes it is in MATLAB. So what is genetic algorithm? It has explained how can you convert this genotype, phenotype to your variable, this x1, x2, all these things is explained. Because it is not possible for me to explain all this in 1 hour. So I have given you whatever best in my opinion. So this is your this binary string, parent string. Once you convert this genotype, phenotype to genotype, okay. Then finally, whatever you will get, that is in the terms of gene actually, gene to genotype. When we convert this genotype to phenotype means it is phenotype means your real world problem. So here everything is given. You can just see that from here actually I have taken this algorithm. Then there are some examples is given. As I told you that people are working with this. This is your fitness function. How can fitness, or you can say that your performance function for the whole population. How you can find this? This is fully dependent on your problem. If I'm working on airlines optimization problem, then this will be something crew scheduling or some aircraft assignments, that function I will take. So depending on your problem. So you have to check. Okay. So maybe 1 minute here that this is the problem explanation. This is actually rounded wheel selection that is given. Okay, multi-point crossover means in my example I have shown you it is 0 and 1. So what we will do, we have replaced this 0 by 1, 1 by 0. So here you can check that this multiple point. So they have taken all these things from this string and copy paste here. Actually they have included here, and you can see that this part here. Actually, so multiple point exchange is there. Why all these things they are doing in that algorithm, so that there will be the high probability of getting the good solution. Okay, so in that office thing, they are getting then combination, then so all theory is there, mutation. Okay, how can it do? Everything is given. Then actually MATLAB coding also given in the last actually I think one, yeah. So slowly, then we will come to that point. So you have to read these notes thoroughly, okay, and go slowly. And this is very simple in that language. Suppose you need any help from my side, okay, in future and whatever. So you may simply see my email ID on the website on IIIT Jabalpur Mathematics Department. You will get that Dr. Deepmala. From there, you can get my email ID and all this. So you can write an email to also me. Okay, my phone number is also given that official. You may contact me. So everything here you can see that I will share. Not now actually because I have another lecture at 4. So maybe by tonight or tomorrow I will send that to the convener. So he will circulate to all of you. So everything is given here. So my suggestion is that first clear the part of modeling, how we have to do the modeling part. Once you done your mathematical modeling, then classification of optimization technique is most important. Then after the classification, you have to choose which technique is better. So I am stopping up to this. If you have any queries, so quickly you may ask. Or 1 minute. Okay, you may ask. Or otherwise, you can also send me your queries by mail also. Okay, and sir has asked me. I think I have to share some question also, so that I will do by tonight or maybe by tomorrow. I will send. Okay. So any other question? Actually, I have to join another meeting at 3. Yes, within 5 minutes. So if you have any questions, so you may ask. Okay, so I think there is no question. So
Okay, ma'am. I think the participants are having no queries right now. They may contact you through mail. So,
okay,
ma'am, let me have the privilege to propose a vote of thanks on this occasion. Thanks a lot, ma'am. Once again, on behalf of Shri Shankaracharya Technical Campus and Mechanical Department, let me extend my vote of thanks to you, ma'am. Thank you for sharing your findings and opinions today in genetic algorithms for modeling and optimization. Especially when you have made the things clear from the grassroots level, which will definitely help for the beginner. So definitely, I can assure you that people may contact you regarding their help and as and when required. Thanks a lot, ma'am.
okay. Thank you, sir. Thank you.
Okay, rest of the participants, you may join tomorrow at 10 a.m.